Right, we'll start the class. Good morning to my dear students. Last class, we discussed about the control of a single acting cylinder and a double acting cylinder and simulation through I shown to you through some videos. Control of a single acting cylinder and double acting cylinder. That means by using a 3 by 2 valve or 5 by 2 valve. 3 by 2 means it consists of 3 ports and 2 position changes 2 positions. We can use maybe a push button or a lever or a solenoid, but there we used a solenoid valves. Solenoid 3 by 2 valve means control of single acting cylinder. In control of double acting cylinder, we used there solenoid 5 by 2 valve. That means 5 ports. It's having 5 ports and 2 positions changes. It is changing positions changing. And then that is also same in the mechatronics lab is also uh, same experiment list. And then in the list, 4 are there. In the next coming class, that means in the next week, we will discuss about that simulation of control of single acting cylinder and control of double acting cylinder. And we have to go for simulation. Thereby it simulates the flow, maybe a hydraulic flow or pneumatic flow. That means power supply. Here the power supply in this here hydraulics and pneumatics, the power supply is nothing but hydraulic power supply, pneumatic power supply. That means uh, pressurized oil or pressurized air, compressed air. Right. Now today we are going to discussing about the mechanical activation system and basic principle and its elements. Actually, the JN2 Kakinada, the framed the syllabus in such a way that this topic is added in the last of this particular unit. If this is added in the beginning of unit 3, then it is good. Actually, in the beginning, it is mentioned in the syllabus, hydraulics system, what is a fluid system, hydraulic system, pneumatic system, and electro-hydraulic and electro-pneumatic and hydro-pneumatic, hydraulic servo, like that it mentioned. After that, it is mentioned in the syllabus, this mechanical actuation system, basic principles. Actually, the framing of the syllabus, my opinion, is not correct. That means if this mechanical actuation system is the beginning of the unit 3, then it is good. And in the next topic of after this mechanical actuation system is electrical actuation system. These two will be the beginning of this unit 3, then it is good. Okay, now we'll discuss about the mechanical actuation system, basic principles and its elements. All of you know that a mechanical activation system, that means a machine or a device, that means if you input to that machine, we can get the output. If the output is not the accurate, or otherwise during this process, when you give input to a machine and then we are getting the output, during this process, maybe some damages occurs more, maybe the maintenance occurs more. That means to function the machine, maybe some wear takes place. So are you understanding? Again, I'm repeating. It's a mechanical actuation system means I'm explaining clearly the introduction. A device is there, mechanical device or a machine or a mechanical system. If you give input to the mechanical system, we can get the output, right? If why this activation system, I'm going to explain you clearly. If the output is not the accurate one, the first thing, and during this process, when you give the input, some processes is going on, and then we can get the output. During this process, some unexpectedly some damage occurs, The maintenance takes place, wears takes place, wear also, and some breakages takes place. So due to the speedy of the process. So like this, there are so many constraints are there. So this, whatever the things what I said, that is one actuation system is there. That actuation system will control the uh, operating or a function of a machine. Now you are understanding, right? So actuation system is nothing but it controls. That means it applies a controlling action on the machine. Controlling action on the machine. Are you understanding clearly? Controlling action on the machine. That is called actuation system. So here a machine or a device, so maybe some improper function, then automatically a actuation system is there. That actuation system is taking place an action on the machine. It activates, so it activates the machine correctly. It activates the machine without any wrong. So for example, see here, the fan is rotating, right? Here, when you go for the regulator, you can go for the help of the regulator. We have to change the mode, speed mode. So then automatically the fan, that means controlling. That means this regulator is nothing but it applies a controlling action on the fan, controlling action on the fan. Example I am saying like that. In this case, this mechanical actuation system is, for example, if you take the ATM, so here some process is going on when you place the card, ATM card, and then some procedure step by step, and then lastly you have to get money from the machine, right? That is machine, that is a machine. Inside, here what is happening, some mechanisms are there. With the help of the mechanisms, without disturbing the process running smoothly, and then we can get the money. So these are, that means actuating. That means here the ATM machine is activating to get the desired output, to get the desired output. That is a mechanical actuation system. That is what mechanical actuation system means. Here what I said out, the actuation system, that means it is applying a controlling action on a machine or a equipment or a device. I don't understand, right? That means here in the ATM, if you type 1,000 rupees correctly, means that controlling is happened inside the actuation. That means through some mechanisms. That is called a mechanical actuation system. Some mechanisms, some mechanism. Here correctly, you are receiving your output 1,000 rupees. For example, if you type 1,200, if the amount is not the raise, the mechanism is perfectly working. That actuation system inside, taking the money and then counting all the things, it is making correctly. For example, 1,200, if it is money is not there, means, for example, the ATM machine will give 300-500 rupees. If when you type 1,200, no, it will not give. That is the controlling action. Automatically displays here sufficient, that means maybe the notes are not available, like that it mentioned. Then you have to go for alternate options by typing 1,500. So like that, it is here the controlling action. When you press the, when you need money 1,200 rupees, when you press the 1,200 rupees, then it will not give if the money is not there. Even though money is there, it will not give. That means if two 500 notes and 200 rupees or 100 rupees notes are available, then only it will be. That means the controlling is happening inside. And then you can get our desired output. If the money is not there, all 500 notes are there, means it will not give. The machine will not give. That means that the controlling action. Automatically it controls. Even though money is there, it will not give. Only if 100 rupees notes, that means 500 notes and 100 rupees notes are there, then only it will give. Right? That is the controlling, the basic control, the mechanical actuation system. Next we will go for this. Here, this actuation system, here this actuation system, these are nothing but control systems. other words, we can call this an elements of control system. I understand. Here, the actuation system is nothing but what is that? Actuation system is nothing but element of a control system. Element. It is one of the element of a control system. It will. That means it's responsible for transforming the output of a. This example, microprocessor, a control system into controlling action on the machine or a device. That means this control system, this actuation system is one of the element of a control system. That means to get our desired output or transforming output, it applies a controlling action on a machine or an equipment or a device or a mechanical system. Now, so now it is clear. Now it is clear. Or to understand what is actuation system, activating system, activation system, right? Activating, right? In other words, activating. Here, my mouth, here I am talking, right? Talking, right? The mouth and the tongue is activating. Here, they're activating. That means here, what is control system here? Anybody? The brain. The brain is controlling. Here, the brain is controlling. So here, when here I am talking sentence by sentence means here whatever that subject topic is stored in my mind, and then this sentence by sentence. So, so here I am not taking the last slide, right? I'm talking the sentence by sentence, right? So these are the things here. Even though, in other words, we can call it as a actuating means conversion. We can also call it as conversion in this mechanical actuating system. In this mechanical actuation system, we can also call it as a converter. Converter. See here in this, for example, if you an electrical output from the controller, which has to be transformed into a linear motion to move a load. That means here see converter, what I said to you, here the output is an electrical output, it is transforming into linear motion. That means it is, in other words, this actuating system, in this mechanical actuation system, the output is electrical. So take the fan. When you move the regulator, that is you can get the electrical output which is reaches to the fan, then automatically the fan speed here is the nothing but mechanical, right? That means angular rotation speed rpm varies when the mode, that means the speed when you regulate the mode, maybe 2 3 4 or 5, automatically the speed varies. Example I'm saying here, this is one of the, it is which has to be transformed into a, that means that the output, the electrical output is from the controller. Here what is controller here? Example, any controller. That means, for example, here in the fan, what we are saying, the regulator is the controller, some fan, by changing the mode, which has to be transformed into a linear motion. There, the transformed into a angular rotation, RPM, in terms of RPM. Example, that is example. Right? There are several examples out there, right? And then another example, the electrical output from the controller, which has to be transformed into action to control the liquid, control the flow of liquid into a vessel. Even the output of the electrical also, we can control the flow of a liquid in a vessel, flow of liquid in a pipeline, control of flow of fluid. Flow of fluid, it may be either a liquid or a gas. That means, in other words, we can also call it as a converter. Converter. This actuation system will convert it according to our desired output. According to our desired output. Next, in the mechanical aspects for motor selections, that is, see here in this, the motor selections, more moment of inertia and torque. Right? I think our moment of inertia is I is equal to mr square. So this one we will discuss it later in the electrical actuation system, motor selection. In the motor selection, these are the two major consideration parameters, that is moment of inertia and torque. Here, what I said now, the mechanical, what I said here, are motion converters. Yes, yes, these are these actuation system. We can also call it as converters. Can also called as converter. That means it converts a linear to reciprocating, or reciprocating to linear, or otherwise linear to angular. Right, right or no? Correct. Linear motion, motion linear to angular. That means mm, uh, maybe sometimes two motions we can convert. One motion is converting into two separate motions, maybe linear and angular. The transfer motion from one form to the another. That means it's converting the motion from one form to the another. For example, see here the transfer from linear motion into rotational motion, right here. See here the linear motion into rotational motion, or rotational motion into a linear motion. Linear motion into a rotational, maybe a rotational motion into a linear. So here these mechanical, these are the, if you see, these mechanical elements. These are the elements of a, some of the mechanical elements are the control systems, control elements. Include the usage of, see here, linkages, cams, gears, rack and pinion, chains, belts, and belt drives, chains and belt drives, right? So these are all the elements we can control the motion. We can control the motion. We can control the motion means here we are controlling the actuation of a mechanical system. I don't understand. Here, these are the mechanical elements. What are the mechanical elements? Linkages, cams, gears, track and pinion, chains, belt drives. So these are all the examples of, these are all the elements of which are controlling the motion, which are controlling the motion of a machine, motion of a machine or a device or a mechanical system. Examples: the force amplification given by levers. So here, this is an example, change of speed given by gears, right? So here that means here this parameter, that means conversion here, change of speed given by gears, and here amplification, force, the enlargement of force is given by levers, and the transfer of rotation about one axis of rotation to the about another. So here, and using a timing belts, right? One axis of rotation using timing belts. That means one axis to, that means so rotational about one axis to rotate. That means changing, the rotation is changing. So if you see the timing belts, opening, open belt and closed belt, right? Crossed belt, right? And all of you know that crossed belt. Crossed belt having two pulleys, right? Then it should be like this. It should be like this, right? That means rotation changes. Rotation changes. While transferring the motion, the one pulley rotated in clockwise, another pulley rotated in anti-clockwise in the cross belt. See here, the cross belt is here. If you see, this is one pulley and this is another pulley having larger diameter. It should be like this. The belt should be like this, right? Correct or wrong? So then, for one, if it is rotating, the small pulley is rotating in this direction, the other pulley will rotate in this direction. That means one is rotated in clockwise, another one is rotating in clockwise. That means here the axis of rotation, if you see clearly, the axis of the rotation transferring. That means one pulley is rotating in one axis, another pulley is rotating in another axis, counter rotation. See here, this mechanical actuation system, this mechanical actuation system. So particularly these, if you see clearly, particular types of motions, what I said, that is a quick return mechanisms, right? Quick return mechanisms, CAM, right? And motion converters, what I said, this actuation system is also nothing but what I said, motion converter. It converts a rotational to linear or linear to rotation, and change of speed by gears and force amplification lever, and see here transfer of rotation by timing belt. See here, if you see in the this force amplification lever, see here, for example, so 1 minute. This is a lever, and here one fixed pivot is there, right? Here the force is added at here. The force is applied at one end of this lever, then automatically the other side of force is applied force is high or so low or equal. Anybody? 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 Here, when the force is applied at here, the other side, the force is high or low? Anybody? See, this side, I'm applying the force. I'm asking this side whether it is high or low. Anybody? So this side, I'm asking this side. When you apply the force, what happens? The other side, the force. And when you apply this side, but 380, right? It's Nagaraj. The force is here. See, when you apply the force at here, see here, here the length varies. Remember this point. The length varies. And what about the force at here? $380, Nagaraj. Unmute yourself. Speak out. Nagaraj. 380. Nagaraj, 380. Nagaraj, 380. Right, speak out.
High, if length increases, the force on the opposite side increases.
Right, very good, very good. Yes, absolute right. Here, see here, if this here, the length is very less. Here, the length is more. Here, when you apply the force at here, here the opposite side, the force getting output is more. So that is high. So that is the force amplification lever, right? That means we can get these are the mechanical systems which can we can go for force amplification. That means amplification is large. First, we are applying small force, and then on the other side we are getting large force. So right. So these are the things. Somebody said that low, right? So when you apply force in this here at this end, then here the force will get a very less. Right? Okay, clear. The next we'll go for the next slide. So this today's topic, all this mechanical activation system we have to know very well. You know very well. Here the types of motion, all of you know that, right? Translational, like translational, rotational, and complex. Complex means that is the combination of translational and rotational. That means including the components of motion in 3 dimensions. That means here complex motion is here it is the combination of both linear and rotational. So these are all the things you know very well. Types of motions, 2 types of motions. That is linear and rotational, right? Another one is complex motion is also there. That is it is nothing but combination of both linear and rotation. And if you go for the next one, here if you see, this is 1 degree of freedom. That means a linear, if you consider any mechanical, this means it moves either in this direction or in this direction. It means it moves from left to right or from right to left. That means only one motion, linear. That is nothing but 1 degree of freedom. So for example, my hand, it will move in this direction or it will move any day. That means rotational, right? Rotational. That means 2 degrees of freedom. This is 2 degrees of freedom. This is moving in linear, or and also here, see here the elbow is rotating, right? elbow is rotating, and then it is also moving. So that is 2 degrees of freedom. This is a 2 degrees of freedom. See here in this clearly, this is a linear, and this is a rotational. This is rotational. Here joint is right, rotational. 2 degrees of freedom. Here the motion. That means here in this what I said to you in the previous the complex. That means what here. So here if you see here. Complex, that is combination of translational and rotational both. If you observe it here in the 2 degrees of motion, it is translation as well as a rotation. This is the translation. This is the translational, and this is the rotation. This is the rotating. See here, you observe clearly. This is a translational linear. That means this one it is moving, and this is this one it is moving in rotation. Right? It's 2 degrees of freedom. So this today's topic, all of you know, this is, already you studied. If you go to 4-bar chain, these are all mechanical actuation systems. See here, this is double 4-bar chain mechanism. All of you know that. This is double lever. This is a double lever. That means double lever. Here, see here. If you consider this is a lever and this is a lever, it is rotating, and this is also rotating. Double lever mechanism. And if you take a lever crank mechanism, if you see clearly, the lever it is moving rotation. So whereas this crank is rotating. See here, this is rotating. Right? Crank is complete rotating 360 degree. And double crank, that means that this link acts as a crank and rotation. See here, double crank, that is double crank mechanism. Here it is only it is moving some angular rotation, but here in a crank, that means a lever, this is a lever and this is a crank. This is a lever and this is a connecting rod. The rod is connected between the two. That means one is a lever and another one is a crank. That one you can call as a connecting rod. See here, are you understand? This is a lever and a crank. The crank is rotating 360 degree. So we can got the lever crank mechanism. And double crank mechanism. That means these two or act as a crank. That means rotation is 360 degree. Double crank mechanism. So with the help of these link mechanisms, so we can get the output. So these one we can arrange in a machine, right? So these are all the linkage mechanisms, or these are making. That means these are controlling on a machine to get the desired output. And then the slider crank chain mechanism. All of you know that the slider crank chain mechanism, right? This is all of you know that if you observe clearly. It is a 4-bar chain mechanism. The 4 links are there, right? This is a 1, right? And see here, if you see, observe clearly. 1 minute. See here, if you observe clearly, this is the crank, right? This is a crank, 1 link, and this is the second link. And the third link is here, it is a fixed link. It is a fixed link. The third link is fixed. And this is a 4th link that is a sliding. This is, see here. Here the crank 1. This is a crank. This link is a 1. We can call name is a. This crank is rotating 360 degree. That is a rotation. Here one link is rotating. The crank is rotating. And then here the 2 link is nothing but a connecting rod, which is connected to the piston. See here, this is a piston, this is a piston, and to the crank. And it is this connecting rod connected to the piston and crank. Right? This connecting rod is connected to one side is piston, the other side is crank. So now this is a fixed one. All of you see here, this is a fixed one, right? A fixed. This is a fixed. So now here the link 1 is rotating, the crank is rotating. So thereby here the output is the piston, here it is moving linear motion. That means sliding, it's sliding. That means the piston is moving inside the cylinder. That means here what we have to understand, it is a motion converter. This link mechanism is a motion converter. It converts rotating motion of a crank into a linear motion or a reciprocating motion to the piston. I don't understand. Yeah, these are that means actuation. With the help of this mechanism, with the help of this actuation system, mechanical actuation system, the piston is operating in the cylinder, operating in the or functioning in the cylinder. That means with the help of these mechanisms, we are getting the output motion. Output, we can get our output. That means with the help of this, that means these linking mechanisms is controlling the output, controlling the output. So this one we can call as a mechanical. Here, what I am telling to you, I will tell you clearly now the difference. So this is a cylinder piston arrangement is nothing but a mechanical device or a machine or an example system, mechanical system. So with the help of this link mechanism, that means a crank, connecting rod, all the things, with the help of this, this is nothing but actuation. It activates the mechanical system, or otherwise it controls the cylinder piston arrangement, cylinder piston arrangement. I don't understand clearly. I'm separating clearly. Here, this is a mechanical, again, I'm repeating, all of you listen carefully. This is a mechanical or system or a device or a machine. Example, mechanical machine is nothing but engine. So here this mechanism, this piston controlling inside the cylinder, the motion is generating, that is the actuation is generating by this one. This is nothing but we can call it as the elements of the actuation system, which is applying action on a controlling action on a engine. Right? How do you understand? How do you understand? How do you understand clearly? How do you understand? So next we'll go for the next one. Cams. I will see cam. Here the, I think all of you know that a cam, when the cam rotates automatically. Uh, See here, you know very well, you've seen IC engines, the inlet wall is moving and the outlet wall is moving, right? So these motions, linear motions are moving, so with the help of the cam rotation. If you see clearly here, if it is this, in this portion, in this, it will rises, this lever rises up, and this is nothing but a dwell. In this dwell, what happens, it is the same. There is no motion, it is in the constant. There is no motion in this one. And when this fall, when it comes in this region while rotating, this is nothing but fall. That means it downs, this one will downs. Means here with the help of the cam, it is nothing but a body which rotates or oscillates clearly, doing some imparts a reciprocating motion or oscillatory motion to the second body. That is called the follower. Here, which is, it is in contact. Means this is in contact. The cam rotates, so the follower is made to rise, dwell, and fall. That means this is the follower here. That means when the cam rotates automatically, this one will rise and it forms a dwell. That means there is no motion, so it keeps as it is, and then it falls. That means it is moving. Here in the engine, the inlet valve and outlet valve is moving, right? Here, if you consider this is inlet valve and outlet valve, it is moving, right, through the cam operating. That means here the cam operating is an actuation system for actuating. What is actuating? Here the inlet valve and outlet valve, the opening and closing. These are all the mechanical actuation systems. And next one, gate trains. I think all of you know that gate trains, right? All of you know gate trains. Gear trains are mechanisms which are widely used to transfer and transform rotational motion. Transfer and transform. That means changing the speed. Speed. That means here, if you see a change in speed or a torque of a rotating device. If you see, when I am traveling in the bike, automatically when I change the gear, automatically what happens? The speed increases. When you increase the gear, when you reduce the gear, automatically speed decreases. That means here actuation changes. Actuation changes due to this gear mechanism. Here, a gear mechanism is also an, that means here a bike is a mechanical system or an equipment. Here the gears is playing a part that is activating the output. What is the output parameter here? The speed. Here with the help of the gears, we are controlling the speed of a bike or a car. Speed of a bike or a car or a bus or a lorry. That means here this is nothing but one of the controlling element. What controlling element parameter here? Speed parameter. Speed parameter. This one, all of you know that. So that is a number of, that means angular speed of this A. Here the gear, here this is a smaller diameter and B is a larger diameter. That means to increase the speed, we have to go for gear trains. And this formula, all of you know that this is inversely proportional. The angular speed is inversely proportional to the diameter, the angular velocity or angular speed, right? Next we will go for next one. Belts and chain drives. All of you know that belt. What I said, this is belt drives is a power transmission, the transmission of power, right? Uh, that means a belt drive is just a pair of rolling cylinders. So these are the rolling cylinders, right? With the motion of one cylinder being transferred to the other, to the belt, through the belt. That means the motion is transforming through the belt. That means one pulley we are arranging. Some here the distance, some distance is there. There is a length is nothing but the distance between the two pulleys. So depending upon the two pulleys, here we have to transfer the motion, and we have to go for belt drives. Use the friction that develops between the pulleys attached to the shafts and belt around the arc and contact. It is not. That means here same. This is also a torque speed transmission of speed. That means in other words, we can call the transmission of power. This is, if you observe clearly, this is nothing but a torque. Torque on the pulley A is nothing but it is the differences of the tensions. That means the tension on the tight side and the tension T2 is the slack side, and the product of the that is the radius of the pulley A, radius of the pulley. So now it is clear. So now it is clear. 1 minute, the phone is getting. Here, see, if you see here in this torque, torque, that means on the shaft A, that is pulley A, that means it is nothing but the differences of the tension in the tight side and slack side, and it is the product 1 minute of the radius of pulley A, radius of the pulley A, right? So this is the, and also torque on torque developed on the pulley B. So this is the same. That is here the product is the product of differences of tensions, the product of differences of tensions and the radius of the pulley B. And next we have to go for bearings. I told to you that this bearings house is here. See, the shaft is rotating. Here the shaft is rotating, and this is oil. That means so to reduce the wear. So this is also the one of the mechanical actuation system. That means to reduce the wear. To reduce the wear. See, these are all the mechanical actuation system. What are the here? What we there are so many. Some of the examples only here we are discussed. Linkages through force amplification levers and cams, cam and follower, and the next belter drives, gear trains, and these bearings. So these are all are the mechanical actuation systems. So here, why here we are going for hydraulic due to this mechanical actuation system. There will be some maintenance, more maintenance are required, and wear should be more. And even though we can get the output, that output is not somewhat not the desired output. So to replace all the things, we have to go for hydraulics and pneumatics for a complicated system. It's very difficult. So to operate or to function, that means maybe unexpectedly, for example, in the link mechanisms, unexpectedly for any joint or a link will breaks, means automatically total, total the process will be stopped. So yeah, like that example I'm saying. So to avoid all the things, we have to go for hydraulics and pneumatics. So now you understand mechanical activation system clearly. If there is any questions, you can ask. You can post a message in the chat box. All of you understand? Now I will take the attendance. Now this the time is 10:50. And then next here one thing here quiz is not uploaded. All of you attempt the quiz at 5 o'clock today, evening 5 o'clock, and it will be enabled up to 9 p.m. 5 p.m. to 9 p.m. Okay, right? So it is not uploaded, but it is there. The link is there. The questions are not uploaded, right? Today from 5 to 9 p.m. All of you, evening 5 to 9 p.m. It is enabled. All of you write the quiz exam, quiz, right? And then next, my advice to all of you, you have to log in through LMS Digiversity. Don't use the Zoom link. Again, I am remembering to you, you have to, whatever the login credentials you are having, you have to log in through your ID and password. Then you have to watch the online live sessions, right? Live classes. Then, so now respond your attendance one by one. Right. 1, 4, 5, 7, 5 option Rama. Right. 8, 9, 9, 10, 10, 11, 10 option Rama. 11, right. 13, right. 14, 10 present. 14, 14, 14, 15, 15, 1, 5, 10, right. 16 present. 17, 16 present. Okay, right. 17, 18, 19, 20, 21, 22, 22, 23, 24, 25, 26, 27, 27, 28, 28, 28, 29, 29 option Rama. 29 option ta. 30 present, okay. 31, 32, 32, 28 present, okay. 32, 33 present, 34, 35, 36, 37, 38, 39, 39, right, 40, 41, right, 42, 43, 44, 45, 46, 48, 49, 48, 49, okay, 50, 52, 54, 55, 55, 56, 60, 60, 61, 63, 64, right, 65, 66, 67, 68, 69, 70, 71, 73, 74, 74, right, 75, 74 present, 75, okay, right, 70 present, 76, 77 present. The next 77, 78, 79, 80, 81, right, 80, 81, 83, 84, right, 85, 85, 85, 86, 88, right, 89, 90, 91, right, 92, okay. Lateral entry 1, 1, 2, 3, right, 4, 4, 5, all right, 6, 7, 8, 9, 10, 10, lateral entry 10, 11, 12, 13, 14, 15, 16, okay, 17, 17, 18, right, 19, 19, 19, 19, right, 20, right, 21, 23, 21, 21, 21, 20, 23 present, okay, 21 option ta, right, 25, 26, 27, 27, right, 27, 28 present, 29, 30, 30, 31, 32, 32, 33, 34, 34, 35, 36, 36, 37, right, 37, 38, 38, 39, okay, right, present 38, present 39, 39, 40, right, 41, 43, 41 option Rama. 41, 31 isolation, isolation, 37 is okay. Then here the option is 35 present, okay, right, and 32 got corona. Lateral entry 32, okay, right. And next, see here, repeat attendance, absentees, number 5, 14, 15, 17, 27, 29, 32, 48, 60, 77, 78, 85, and lateral entry 10, 21, 29, 34, 41. Anybody else? Seventeen members are absent. Okay. Okay. Thank you, all of you. Seventeen by 369 present. Okay, already present. I given present. 369 present. Already you responded. 369 present. Okay. Okay. Thank you, all of you. Three 74 present. 374 present, Amma. 380 also present. Okay. Thank you, all of you. Then today's quiz you have to write down from 5 o'clock onwards. 5 o'clock it is enabled up to 9 p.m. right? 78 present. 78 present, Amma. Okay. And 69 is also present. Okay, right. Okay. Anybody else? Okay. Thank you, all of you.